Welcome, ladies and gentlemen, to this presentation of a 4-bar mechanism. What is a 4-bar mechanism? It's applied to many industrial and general mechanic applications. It is made of 4 rigid elements joining together and the This is made sliding joints. This is a Grashof mechanism, and this is the science shortest link in the framework of theme, double crank. This is a movement analysis. For the simulation of the movement, the angles of the coupled link and the follower in the mechanism must be obtained. For speed and acceleration, the angular and linear velocities of the links are calculated using kinematic relationships between the links and the no inputs of angular velocity of the drive link. How did we solve it? The angular acceleration of the link are denoted as acceleration 2, 3, and 4, where 2 is the angular acceleration of driving link. A3 and A4 are coupled follower links. As we can you see, the results of the operation coincide with the simulation. This begins the interested angles of the node of the moment. The first bar is added from the left to right for the direction of a correct x vector. Then the magnitude and angle it was added. Then you put the second link for the left to right, so that direction of the vector is correct. Then you put the magnitude and the angle. That is in this example. How did I solve it? The position analysis with SolidWorks. In order to know the angle 3 and 4, the bar must be first be drawn, but to be able to do so, as a circle must be first placed with the radius begin safe as the bar number 3 for the second bar. For link 4, another circle must be drawn for the first link with the radius begin the value of the magnitude of the link 4. To finish, first draw link 3 for the left to right and link 4 for right to left and the intersection of two circles.
How do we check that the bar are correct? To check if we did it right, we review the results obtained previously and we find that the bar has an angle of 358.8 .808 degrees, and for bar we calculate that it has an angle of 215.204 degrees. Velocity and acceleration analysis in SolidWorks. Below the results of the exercises and are detailed taught as speed analysis with SolidWorks. The following graph shows the path of the bar with a 60 revolution per minute motor on the fixed bar. And to create this trajectory, we will go to SolidWorks to the motion analysis part, which is located on a timeline in our program, showing these images. We will work only with displacement, velocity, and acceleration. Depending on the edge of the analysis to be carried out, we will choose the specialized subcategory and always having the component resulting in magnitude if this gives us the option. If not, we continue with the following. Remember to check the box in the window to show the vectors. We have to select the bar or rotor that needs to be analyzed, and with this we have everything necessary to do the analysis of the following subcategories. Below is the linear speed of link A Below this is below is the liner speed of part A, where its speed is 300 3000 its speed is 3192 millimeter per second. With angle with the angular velocity, as we can see in the following figure, it has a peak in the second at 0.18 second. In the seconds at 0.18, with the maximum velocity begin 1050 1500 1544 degrees per second. And the angular acceleration in each link is related by the kinematic equations of the mechanisms. To calculate the angular acceleration of a link, the method of relative velocities and accelerations or methods based on the equations of motion are generally used. And this is the velocity graph analysis, and this is the acceleration graph analysis. And well, this is the simulation. And in the conclusion, in a 4-bar mechanism, all parts are connected to each other. As one part moves or changes speed, the others reacts. The design of this type of mechanism takes advantage of the interconnection between the parts to achieve controlled and efficient movements. Each element fulfills a specific role that depends on this interaction with the other, which promotes the coordination operation of the system in a harmonious way. And this is the end of the presentation. Thank you.